couple of comments and or questions relative to the holding times, and it seems like an aspect that might be valuable to help us get our brains around all the probabilities of all these separate time points or places in the supply chain where there might be variances, to add some type of at-risk or Monte Carlo simulation process where you can have 10, 50, 90 scenarios around the different factors and help us get our brains around the probabilities and the best outcomes that we could expect, given that you're not going to have just a static data point for each one of these steps in our supply chains. And then the other comment would be to thank everybody for all the great work that's been done on identifying which ingredients and how viruses might survive in them. So you've done a nice job of showing if I add virus to something and I simulate a process that it could show up here. I think one of the places where we're lacking is an assessment of the actual risk of a virus getting into an ingredient at the manufacturer or the origin, and how do we accomplish that? And it may actually take an approval or an auditing process of every manufacturer, but there aren't that many. So as an industry, it seems like maybe we could come up with that risk assessment.
Any comments, guys?
I think those are great ideas, and I can't answer any of the questions. I'm just going to assume that everything's contaminated to start with, and we'll work with that first and then refine it as time goes on. But that's clearly where we need to go. That's a much better approach than just assuming everything's a mess. So thanks for asking the questions.
So the question of, are the products contaminated? I mean, that's the first thing that I ask, right? So yes, you can inoculate anything, and most likely it can survive, but what's the likelihood of contamination? And we keep asking that. It's very low in some of these ingredients, but how do I prove that to you, right? And so if I could, I would take you all to these facilities and let you walk through them. You guys probably don't want to do that. I don't know that we'd get in the country, or around the world. It would take, an enormous effort to do it. And so how can I best tell that story to you guys? And that's where we've tried to talk about a meeting. Can I get enough of the influencers in the room for you all to hear it from our companies, from the suppliers, from the import brokers, so you guys can feel comfortable enough with what's there, whether I'm showing you videos or pictures, or it's just the oral story that's told for how it goes. The idea of a certification program, an audit, that kind of thing, we've got FAMI-QS is an international-based certification program that is out there. They don't really get into this aspect of it. Is there additions that could be added? Possibly, but what are the questions that need to be asked? Those are the things that we've got to get down to. And then again, an audit is a snapshot at that one time, right? So making sure that, I would rather spend more time making sure that they're put in place every day and for everything that's going on, than maybe focus time on establishing something that could take a while for us to get up and running. Does that make sense?
So Scott, one thing I want you to clarify. I want to make sure that everybody's clear on what you're talking about with the 30, 10, and 20 days holding time. Is that the holding time on arrival in Des Moines, or is that holding time leaving Beijing?
Yeah, so this is the holding time on arrival at the site in Des Moines.
Yeah.
It's based on the titer decay over time during shipment and how much virus is left, mathematically speaking, and then doing the half-life calculation off that.
Okay, all right. And so, for example, and Paul, okay, and Tim, go ahead. All right, I'm just putting this up there as 30 days is going to cover both of those viruses, considering 30 days, just as a starting point. Go ahead, Tim.
And that's after we get it, really, Scott. So we get the product in Des Moines or wherever, then you got to hold it 30 more days.
Right.
Yeah.
That's based on the titer on arrival, i.e. Des Moines in the model.
Yeah.
And then
And
after that. Yeah.
I just want to make a little bit of comment. Yesterday scared me a little bit. And Paul, you were talking about good manufacturing or bad manufacturing, or there's heat treatment in the manufacturing, and so that should be good, and it's low risk versus high risk. But in that Russian case history of that pig farm, it was good location, good wall and fence and shower in, and somebody had pigs at their own farm that ended up having African swine fever, and they brought it in, and hopefully they showered, but and so all that stuff to me doesn't matter a lot. Do they have good manufacturing? Somebody, the truck driver who handles the product, or somebody working in the plant could contaminate it, and so we're doing downtimes every day on farms. We have so many nights down, shower in, this product gets fumigated, this product gets ultra. I don't think this will be hard to teach and do if you don't make it too complicated. This product is this many days, and this product is this many days, and this. Give ourselves a bunch of cushion and just say, if it comes from these countries, it requires 40 days. You know, that's what we do every day, Scott, on pig farms. They have a little set of rules, and we shower and do everything like that. So I think hold time in general and get it whole, make it simple, and it'll be done.
So one of the things, and Tim, I think that you bring up a really great point. We get so much discussion and so much question about feed and feed risk and hold times or not, or mitigants or not, and so much about feed. That might be one risk that we're under. There are so many other things that we can't lose sight on. We can't just focus on one thing and think that we're going to be safe. It's a great point about biosecurity, in, out, all of those other things. This is one of the windows. There are a lot of others, too, that we've got to continue to work on.
Yeah, so Scott, my question is on the days, those were done at ambient temperature, or is there a specific temperature there?
So the half-life calculation was based on the data that were generated during the 30 or 37-day journeys. And those each day had a range of temperature and relative humidity conditions based on historical information from across the ocean, across how the journey would actually happen. Oh, thanks. So it wasn't a straight line. The range?
I'm talking about the 30 days here.
Sure, okay. So in that Trans-Pacific model, the range of temperatures that we experienced in that model was about 5 degrees C to 10 degrees C. And in the transatlantic model, it was approximately 10 degrees C to 20 degrees C. So we do have some idea of where the temperature line was to get that viral decay. So 20 degrees C is roughly room temperature. So it might be a starting point on where you would the environment you would try to set up for a storage period.
So it's roughly room temperature.
Roughly room temp. Maybe a little warmer wouldn't hurt, but obviously we don't want to injure the quality of the ingredients, so we've got to be careful there.
But 30 days at a minus 10 C is going to be different than 30 days at 20 C.
Yeah, that's the amazing thing about these virus survival is those weren't very friendly conditions for viruses that we used in the studies. 4 degrees at the low point, that's not very, very cold. Yeah, so it'd be very different if it was typical Minnesota, minus 20, minus 30 Fahrenheit.
Paul.
Okay, Gene, and go ahead, Gene.
Paul, this question's for you. I have to commend you and SHIC for what you've done so far to lead this. And I see that we've got a lot more to do. How are we going to continue SHIC? And you and I had a little conversation, but I think educate us, help us to help you to keep this going.
Okay,
because it can't stop.
Good, thank you.
As we move forward.
Thanks. All right, so here's the deal. SHIC was formed as a rapid response, I shouldn't say response. It was formed as a flexible, rapid way to monitor, prevent, and respond. The other organizations do that as well. But SHIC, the idea behind this organization is to fill in the gaps, the things that aren't happening, get it done quickly, take a look at it, and then hand it off. So this feed issue is a great example of that. The National Pork Board didn't have a research fund for feed issues. We're going to throw that in there, and we're going to make this happen proactively, and good thing that it happened, because now, as Scott said, we've got some things on the front side instead of the back side. And now the National Pork Board in their 2019 budget has an item line specifically, it's still proposed, but it has an item line specifically for feed safety related research. It's exactly the thing that's supposed to happen. That identify the things, fill the gaps, do it quickly, go on to the next thing, and let the Pork Board or other funding agencies take it up. That's the concept. I think this is a really good example of it. The Pork Forum delegates in March passed an advisement that said that SHIC should continue to be funded at a level determined by the National Pork Board. They're looking at ways to make that happen. So that discussion's starting, and I thank you for the comments. That discussion's starting, but this is all about that working groups and the board of directors and everybody else that makes this thing happen. That's enough for that commercial, but thank you for that one. Let's see. We had Mike over here too. What do you have over here? Okay, there.
I want to thank you for the nice job on all the time spent on this work. One question, is there any work being done on heat or radiation or the other avenues to kind of clean up feed or ingredients?
Yeah, I'll take a stab at it. That's a good one for you. Yeah. So based on our work at K-State as well as a collaboration with Dr. D, South Dakota State, the primary approach at this point is mitigation through feed additives, various feed additives, medium chain fatty acids, formaldehyde-based products, which do have the residual duration of activity that help them prevent from subsequent recontamination and the issues associated with that. The advantages of a point-in-time strategy, thermal irradiation or thermal processing, are very prone to subsequent recontamination. So the focus at this point with the continued research is through those residual duration approaches.
So one of the other challenges with the radiation is the lack of facilities. We just don't have the facilities available to irradiate everything that we would need or want to irradiate. You'd probably end up having the holding time that you may be looking for while you're waiting to get it irradiated. With heat, a lot of this stuff is on pallets, so getting it high enough to get that heat to the middle of the pallet, into the bags in the middle of the pallet, those are all consideration. And then what does that do on the stability of the ingredients?
Jerry.
Leah, while you have the microphone still, thank you for coming. I think it's great that the feed industry is represented at this meeting, and I won't make any jokes about walking into a room full of veterinarians, but we really are happy that you're here. Scott and Luke and everyone is raising a really important question about responsible sourcing, and we're still capitalists, and we're in a really hard market and might not dig out of it very soon. This is a long way to get to a question. Some of us jokingly, unfortunately, use air quotes when we say Chinese organic soybean meal, and so a serious question, how rigorous is the classification of components where people think they're getting something, and should we stop joking about that, or is it legitimately these specialized products that people are paying premiums for.
So question more on, is it truly organic when it's coming in? Is that what you're?
Yeah.
Well, that's out of my wheelhouse. But, I mean, we do have systems that they're supposed to be certified organic. I know that there are concerns, and there had been some fraud in that system, and that's something USDA is looking at, but not my area of expertise, so sorry.
Tim?
Why don't we just do it ourselves?
Yeah.
We make some pretty good soybean products here.
Yeah.
We can make some organic stuff.
Go ahead, Tim.
All right. Thank you. Thanks for this discussion. Very much appreciated from my end. I think, a lot of the discussion, I think we've established very well that organisms can survive in certain ingredients, and we're exploring mitigation. And I think the first question sort of alluded to what I'd like to talk about, and that is, we've established that essentially what we're being asked to believe, and I think what we believe, is that along the supply chain, there's high potential for gross organic contamination of ingredients, be it at the feed mill level, at the harvest level, at the manufacturing of microingredients level, and all the ingredients that go into that. Essentially, we're looking for where can that event happen. And I'd feel a lot more comfortable. I think we're making the assumption, like Scott says, we're at the point where we have to take the precautionary approach, because it's a pretty big supply chain and it's pretty hard to control and understand exactly all of the flows. And so we need to take the precautionary approach and focus on mitigation to some degree, or simply avoidance of certain products if we don't know. But I think in any risk assessment, we always look at the likelihood of contamination, and as well, if it is contaminated, the likelihood of survival, and if it survives, the likelihood of consumption and infection. So we sort of have to look at all of those aspects, and I feel a lot more comfortable if we work at going up the supply chain and looking for those points of organic contamination. I've been on a lot of feed mills and assessed a lot of feed mills for biosecurity, and I think everyone is an individual, and some are a lot better than others when it comes to all of the events that happen at the feed mill, and where bulk ingredients are taken into the flow. And there's often things that you'd never think of as far as how organic material can get in there. And like is it Jordan? I'm sorry, from KSU? Yeah, said that, once it's in there, it's difficult to get rid of. So I really appreciate the discussion, and just want to make those comments. Thank you.
One more. I wish we had an hour to do this, but unfortunately we don't. Anybody want to offer another one? Okay.
Dr. D, I'm really interested in your comments that you said, and I agree with you, that none of these mitigants actually that you tested sterilize feed, which would be probably beyond the scope of what they could do, because that feed would have to almost be autoclaved. But I am interested in that you've conducted former research showing that mitigants used with contaminated feeds prevented infection in the pigs, and that was done with PEDV. Would you like to explain the difference of why, and that was done with not feeds that had any storage period at that period of time. So would you like to explain the difference between the research then and maybe some of the statements that are going on now?
Quickly.
Yes. We probably reduced the dose to a point where it couldn't infect pigs anymore. Based on the change in CT value over time of that work, we showed that it went from 25 up to almost 37. So viral load was clearly going down to a point where it just was maybe RNA left over, nothing live. Be my guess, Mark.
Okay, it's noon. I got so many comments from people say, just tell us the number, tell us what we need to do, give us a number so we can do something, because we want to do something.
Is that coming now?
Is that coming now? Yeah, write it on your hand, Tim, right there. What we've tried to do today is show you what the research says and show you the process that you can consider the different categories of feed and feed risk, and then look at a half-life calculation and a holding time that will enable you to get to a spot where you don't have to do 10 days for one, 5 days for another, 30 days for another, and 15 for a fourth. And so I'm hopeful that that's come through. I want your feedback. We need your ideas. We need the continued discussion. And thanks for attending and holding with us. And if you'd help me one more time, thank our speakers for their